Okay, so as I mentioned in this section, we are going to continue on with interest problems, using formulas to calculate those. And it's going to be a little bit more involved, okay, than what we have been doing. All right, so let's go ahead and start. And again, these are going to cover sections 7.5 and 7.6 in your book. Okay, so here it says to help pay for culinary school, Heather borrowed money from her credit union. She took out a personal amortized loan for $59,000 at an interest rate of 5.55% with monthly payments for a term of 15 years. Okay. Again, it says here for each part, do not round any intermediate competitions and round your final answers to the nearest cent. Okay, so that's important because again, if you round, keep rounding, then you're going to be off from the exact answer. So you want to keep much information about your data in the intermediate steps, so that when you get your final answer, it's not going to be off. Okay. So if it has a bunch of numbers after the decimal point, then you keep those numbers. Okay. So we want to find Heather's monthly payment. If Heather pays a monthly payment each month for the full term, find her total amount to repay the loan. If Heather pays the monthly payment each month for the full term, find the total amount of interest she will pay. Okay, so in the resources, you will find three formula sheets, and you want to look at the last one, final formula sheet, part 3, and it has these conversions here. So, so the one that we need to use is the one on the bottom right here, where it says M is equal to P times R over 12 divided by all of this information. Okay, so this is the formula we need to use to calculate Heather's monthly payment regarding this personal loan. Okay, so let's go back to that here. All right, so I already made a copy of that here. So in this case, M is the monthly payment, P is the principal, R is the interest rate, and T is the number of years that payments are made. Okay, so that's what we're going to be using to solve this. Pause for a second. Okay, hopefully you started filling this out and filling out the information that they gave us. Um, the hardest part about this is how to enter this in a calculator for a lot of students. Okay, so hopefully we can clear that up and so you can get this answer correct. So the first part here we have again P is the principal or the amount borrowed. All right, so in this case that's going to be the $59,000. All right. R is the interest rate of 5.55. So we need to convert that to 0.0555 divided by 12. Okay. So that's going to be in our numerator, the top part. The denominator will have 1 minus 1 plus. R again is 0.0555 divided by 12. And then raise that to negative 12 times t. In this case, we want 15 years. Okay. So we're going to multiply that by 15. Okay. So what I do first when I attack this problem, again, you always want to think about PEMDAS. Please excuse my dear Aunt Sally. So you focus on the parentheses and then the exponents. Okay. So, but I want to calculate this part here, the negative 12 times 15. So if I multiply that there, negative 12 times 15, I'll put that in a calculator, that gives me negative 180. All right, so I get that out of the way. All right. So now then I follow this, right? So I'm going to focus on the numerator. So I'm going to do this first. You got 0.0555 divided by 12. So that's what I'm going to do first. Pause for a second. Okay, so 0.0555 divided by 12. All right, so I get that answer. Then I want to multiply by 59,000. Too many zeros there. All right, so then we have this answer, 2728.75. So I'm going to write that for the top. So 272.875. So notice I'm not rounding, I'm not putting 0.9. I'm putting all the numbers that the calculator gave me. Okay. All right, now let's focus on the denominator. So again, we're going to focus on the parentheses first. So we have 0.0555 divided by 12. All right. And then I'm going to add add the 1. So add 1. All right. So I get this number here. Then I'm going to raise it to the power, right? Because now I finish what's inside the parentheses. Now I need to do the exponent, the power. And I already calculated that. That gave us negative 180. So I'm going to take this number here. Okay. And then I'm going to raise that to negative. Don't use the minus sign. Again, don't use the minus sign. You need to use the negative power there or the negative button. Again, don't use the minus sign. You'll get an error. So you get 180 here. All right. And then this is our answer for the denominator. Well, for this part here. Okay. Then don't forget there's the 1 here in the front. So we have to take 1 minus this number. Okay. And then that's our answer for the denominator. Okay. So again, I want every single one of those digits. Right. All right. So put that in the calculator. So again, I have 272.875 divided by that decimal answer. Okay. So we get $483 and it says round to the nearest cent. So that would be 65 cents. $483.65. Okay. As I mentioned, typing in the calculator is probably the biggest obstacle for some students. Okay. All right. Any questions on how to enter that in the calculator or how we got that answer? Okay, so let's go to the next part then. Again, it says if Heather pays the monthly payment for each month for the full term, find her total amount to repay the loan. Okay. All right, so we want to just find her total amount to repay the loan. So we just take the 483.65, okay? And then we're going to multiply that by there's 12 months in a year, and then she's doing this for 15 years. So her total repayment is going to be $87,057. Okay, so that's her total repayment there. Okay. And part C says if Heather pays a monthly payment each month for the full term, find the total amount of interest she will pay. Okay. So again, this is similar to the housing that we were doing. We just take the amount that she borrowed originally, right? And then we subtract that from the total amount of payment that she made. Okay. So just take the $87,000, okay, and subtract 59,000. Right, so when we do that, we get $28,057. All right. So that's the answer for part C. All right, so it says here, Dan plans to purchase a new sports car. The dealer requires 10% down payment on the $42,000 vehicle. Dan will finance the rest of the cost with a fixed rate amortized loan, auto loan at 4% annual interest with monthly payments over 5 years. Okay, again, do not run any intermediate computations. Your final answer to the nearest cent if necessary. All right, so we want to find the required down payment. All right, so the vehicle costs $42,000. Okay, so the dealer requires a 10% down payment. Right, so we just take that $42,000 and then multiply by 10%. So that's going to give us $4,200. Okay. All right. Now we want to find the amount of the auto loan. Well, he's not going to take out the $42,000 because he's paid $4,200. So we have to subtract that. So $42,000 minus $4,200. And that gives us $37,800. Okay. So this is the amount of money that he will need to borrow to get this car. So now we need to find the monthly payment. So again, when it's asking for the monthly payment here, we'll use this formula. Okay. So P is the amount that he's going to borrow. So that's the $37,800. And R is the interest rate. So that's the 4%. So 0.04 divided by 12. And then 1 minus 1 plus R again is 0.04 divided by 12 raised to the negative 12 times how many years? 5 years. Okay. All right. So using this type of formula, the top part here, again, I'm not going to go through all the steps again because it's going to take, it's the same steps. Okay. But the top part, you should have received 126. And the bottom part, you should have received 0.180996896. Okay. So when you divide the two, you should get $696.14. Okay. All right, so for this next problem, it says Ryan's taking out a mortgage for $148,000 to buy a new house and deciding to between two offers, the offers from two lenders. He wants to know which one will be the better deal over the life of the mortgage loan and by how much. Okay, so we're going to compare two mortgages here, one for 15-year and one for 40-year, and they want us to find the monthly payment again using this formula. Okay, so for the first part here, again, I'm just using this formula here to calculate this. We have 148,000. Okay, multiply that by 0.032 divided by 12, and then divided by 1 minus 1 plus 0.032 divided by 12 raised to the negative 12 times 15. Okay. All right, so for this one, again, just try to be conscious of time here. Uh, when we enter the top part in the calculator, we should have got 394 point, a lot of sixes here. 3, 4, 5, 6, and then I just round out to 7 because it just keeps on going. And then the denominator here, I got 0.3808211,632. Okay. And then for the answer for that one, put this down here, we get $1,036.36. Okay. All right, so for part B, we're going to do exactly the same thing. Pause here for a second. Okay, again, using the same formula for the part B there, we'll need to write down 148,000 multiplied by 0.032 divided by 12. Okay. Again, it's the same interest rate, right? 3.2% for both of them. And then 1 minus 1 plus 0.032 divided by 12 raised to the negative 12. And then the difference is here is instead of writing 15, we'd write down 40. Okay. Which seems like a lot. I've never seen a 40-year mortgage. But guess they have them. Okay, so anyway, for the top, we're going to get the same thing as we had before, right? Because it's the same information. So that's 394, 6, a lot of sixes, 7 there at the end. And the denominator, we're going to have 0.72148866707. Okay. All right, so when we divide this in the calculator, we get $547.02. Okay, so let's now answer part C. Okay, see if we can figure that one out. Okay, so part C is asking, suppose Ryan pays the monthly payment each month for the full term, which lender's mortgage loan would have the lowest total amount to pay off and by how much? All right, so for the bank one, we just take the $1,036.36. Let me do that. Let me rewrite that part there. So $1,036.36. Then we're going to multiply that by 12 months and by 15 years, right? Because it's a 15-year mortgage. So when we do that put that in a calculator, we get $186,544.80. Okay. So that's for the 15-year. For the 40-year, the online banking one, we're going to be doing 547. It's such a much lower payment, which is very attractive. Okay, but let's see what happens over the 40 years. So times that by 12, times that by 40. Okay, and that gives us $262,569.60. Okay. So even though it's a lower payment, right? Again, it's the bank one, it's almost double the one for the online one, right? So a lot of people are going to pick this one because you're paying a lower payment. However, in the long run, it's not going to help you, right? So when we subtract these two, we get $76,024.80. So you're paying an extra $76,000 to get this 40-year mortgage. Okay. So, so the bank one is going to be the lowest to pay off overall, right? By this much money, by the $76,000. Okay, so this next question we have, it says Betty Smith purchased a jet ski for $5,700, paying $750 down. The balance was financed for 23 equal monthly payments, and Betty agreed to pay a $573 finance charge. Okay. Using the APR table, calculate the following to the nearest hundredth. Okay, we want to find the amount financed and then the annual percentage rate, APR. Okay, so how do we do this? So first of all, how much do we need to finance? Okay, well, Betty is purchasing a jet ski for $5,700, so she's paying this much in down payment. So we just need to take those two numbers and then subtract them. Okay, so when we do that, we get 49.50. Right? Now to find the APR, all right, the annual percentage rate, we have to go through these steps. So let me write those steps down. So step number one, we need to locate the row of payments. It says row there. Row of payments. Step number two, find the closest, find the amount closest. Okay, I'll leave that blank for now. And then three, follow the column to the very top for the APR. Okay. All right, so just to do an example of the steps, I have one here, a chart. Okay. So on the next slide, it said, okay, so but it says the first thing is we need to locate the row of payments. So it will tell us that in the problem. Okay. So in this case, again, this is just an example. So the number of payments for this one would be 20. All right. And then whatever number we calculated, right? So we need to pick the one closest to it. So if it was $11.54, then $11.53 would be the closest one. Okay. Or if it was $11.52 or whatever. Okay. So find the one, the value that's closest to it. Because as you can see, not every single number is accounted for. Okay. So again, you find the number of payments, you go to that row, and then go to the one that's closest to the number that you got. All right. And they got 1153 here, and then you go all the way up, and then that will tell you this top number here, the annual percentage rate. Okay, so that's the process we're going to be doing this. Okay. All right, so first we need to find this 1153 or this number here. Okay. So in this one, um, to find this closest number, right? This is what we're looking for. Okay, we're going to take the finance charge, divide that by the amount finance. Okay, and then we're going to multiply that by 100. Okay, so the finance charge is $573. So I put that on the top. And then the amount finance is the 49.50, right? That's the amount that Betty is going to borrow. So put that in the denominator. And then we just multiply that by 100. Okay. Okay. So when we put this in the calculator, we should get $11.58. Okay. So $11.58. So this is the number we need to look for in the chart. Okay. 1158. All right, so I have a different chart here. Okay, because each chart is going to vary depending on the amount. So if I go to this chart, I know that's not the best scan, but this is what I have. So, but let's go back to the problem though. It tells us we need 23 equal monthly payments. So that's the first item, our first number we have to go to, locate the row of payments. So that's 23. And then after that, we're going to go find the number that's closest to 1158. If they have 1158, great. But if they don't, then we have to find that number. And then once we find that number, the closest to it, then we go to the very top to find the APR. So we want 23. So 23 is right here. Okay. That's the number of payments. So I look for 1158 and I don't have 1158, but the closest I have is 1163. Okay. So again, I don't have 1158, but the closest I have is 1153, 63. So then I use that number there, then I go all the way up and then that tells me my APR. So 11.25%. So the answer here is 11.25%. All right, so the next problem here, we're going to look at this credit card statement. It says, here's Allie's credit card statement for the month of September. I know it's kind of a little bit hard to read here, but the first table here has the date, the transaction, and the transaction amount. Part A says, use the credit card statement to help fill in the table below. Note that there are 30 days in September. Also, purchase increases the unpaid balance and the payment decreases the unpaid balance. So here on this table here, the second table here in the middle, you have the date, the transaction amount, the unpaid balance, the number of days at that balance, and then the unpaid balance times the number of days. Okay, so we need to fill out this chart here and answer these questions. Okay. All right. So let me pause here for a second. Okay, so we have to understand what this credit card statement is saying. All right. So if we look at the September 1 row, okay, um, it has this unpaid, so I kind of written up here because I know it's kind of hard to see, but it says the unpaid balance times the number of days. So the unpaid balance is $14,004. So how are they getting this much here? Well, all they're doing is multiplying the $14,004. Okay, and then multiplying that by the amount of days it's been sitting at this amount. Okay, so this is how credit card works. Okay, so they just multiply these two here, the $1,400.04, multiplied by 13, and you get $18,212.52. Okay, so that's how they got that number. And basically, that's what we're going to be doing for the rest of these other cells. So let's look at September 14. Okay. So remember, this is the transaction, so the amount paid balance, and then Ali made a payment, right, of $650. So we need to subtract that, right? So the $1,400.04 and subtract that $650. And so now her balance is now $750.04. Okay, because again, she made a payment of 650 bucks. All right. So now we need to find out, okay, what the unpaid balance times the number of days when it was sitting at this particular number. Okay. So, September 14th through September 17th. So they're going to count the date itself, 14th. Okay, so that's one day. September 15th is the second day. September 16th is the third day. And September 17th is the fourth day. So here we will put 4. Okay, so this is 4 right here. Okay, so then we just multiply those two numbers, the 750.04 times that by 4, and we get 30,000.16. Okay, so $3,000.16. Okay, all right, then we go through the same process again. So this time again, this is her unpaid balance, and then she makes a purchase. So she buys an item. Maybe it's a pair of shoes. I don't know, maybe it's a clothing item. Okay. So she paid $98.15. So we're going to add that to her balance. So that gives us 848.19. Okay. So $848.19. Okay. And it was sitting at this number for 6 days. So we're going to multiply those together and we get $5,089.14, right? So essentially, this is the weighted averages that we talked about before, right? So this is what they're doing. All right, and then she makes another payment of $300. So we're going to subtract that. So 848.19 minus 300 will give us 548.19. Okay. All right. And then they already told us September 24th through September 30 is 7 days. So we're going to multiply that. And we get 3837.33. Okay. All right, and then we add all this, but don't forget to add this one. Students forget to add that one that was calculated for us already. So don't forget this one, that number. All right, so anyway, so we add up all of these numbers here. Add up, okay? And we get $30,127.15. Okay. So what are we trying to do? Well, we're trying to answer now part B. We want to find the average daily balance. Okay. So to find the average daily balance, we would take this number that we got, the total, and then divide it by the number, the total days. So that would be 30. So take that number, divide it by 30. Okay. So when we do that, we get $1,004.24. All right, so let's look at part C now. It says, suppose that credit card company charges an interest rate of 1.5% on the average daily balance for September found in part B. How much interest will be charged? All right, so all we have to do there is we just take the $1,000, $1,004.24, and then multiply it by the interest rate. So that's going to be 0.015. So that gives us $15.06. Okay. All right, so that is the uh, interest that will be charged on your account. Okay. All right, and then part D says, what will Ali's beginning balance be for the month of October? So go ahead and write that down. What do you think? Okay, so we need to find the what will Ali's beginning balance be for the month of October? Okay, so all we have to do is her ending balance for the 30 days was 548.19. So we take that much or that money, okay? And then we're going to add that by the interest rate of $15.06, or how much interest charged. Okay. So we just add those together and we get $563.25. Okay.